Hello guys, welcome to my channel. This tutorial about deep learning. This is a first part, this tutorial about deep learning with Python. And I want to show you how to make a deep learning and how to make artificial intelligence with Python. And this part about we talking about a convolutional neural network. We talking about object detection like handwriting and detect with image and another things. Okay guys, and at the end of this video you can make your first model and neural network, and your model can detect handwriting object from image. Okay, let's go to coding. This is a Google Club and I want to use this platform because it's free and it's very fast, and I setting that for GPU, and I'm using two GPU connection for that. I connected that and starting to listening. Okay, I'm not a robot. Maintain okay, verify that. Okay, connection. And today is first part. I'm show you image classification with MNIST dataset. MNIST dataset. MNIST dataset is a very good dataset, and including the handwriting object like this. Handwriting object like this, and including 0, 1, 2, 3, 4, and it has labels for every object. My training has 60,000 image, and I think 1,000 for test imagings. Okay, let's go further. When you started deep learning with different neural network architecture, you realize that one of the most powerful supervised deep learning techniques is a convolutional neural network. Also, you know CNN. The final structure is CNN is actually very similar to regular neural network, and where are neuron with weight and base. In addition, just like regular net, we use a loss function, cross entropy or softmax, and optimizer. Optimizer like Adam optimizer in CNN. Additional to the CNN, there are also convolutional layer, pooling layer, flattening layer, layers, and CNN are mainly used in image classification. Although you can find applications such as natural languages processing. Pooling and layer, I show you and explain you in continue. There are conventional pooling layer, flattening layer, and in other things. In today, this lessons, we have MNIST dataset. MNIST dataset, a gray scalar images, and has 28 one neuron layers. Because my image, every image has 28 pixels. And if we have used another image like not gray scaled. Therefore, assuming that we have get set of color image in 4K Ultra HD, we will have like this parameter you see here. Because I use 3 because gray and not gray scaled, we have 3. But in a gray image we have 1. Okay, guys. Going to done, and this is a architecture neural network and another thing. This is a layer in CNN is a convolution layer. Convolution layer is a very fast layer, and we extract features from the images in our database. Convolution allows us to preserve the relationship between different of image. Convolution basic filtering in image with a small filter and decrease size image without losing the relationship between pixels. We apply convolution to 5 multiply 5 image by using a series filter with Wonderfont strat. Because you see this my image, okay, we use the filtering, and I used a filter, that 3 multiple 3 filter. I achieve this image. Okay, first convolution to 5x5 image by using a series filter with a 1x1 straight. It is very, very important, you know. Okay. One pixel shift each other. If we use a 3 and 3 filter, we have a 1x1 straight, and this is a shift in image. Okay, guys, going to find fully connected layer. I want to say you pulling layer. Pulling layer, when constructing CNN, it is a common to insert pulling layer after each convolution layer to reduce the spatial size of representation, to reduce parameter count, to reduce a computational complexity. In addition, a pulling layer also help with the overfitting problem. Basically, we select a pulling site to reduce amount of parameter by selecting maximum, average, or some values inside the picture. Max pulling, one of the most common pulling technique, may be demonstrated as follow. Like that, pulling layer, for example, this area 5 is maximum. I write this here. This area 6 is maximum. I write here. This area 4 is maximum. I write here. Pulling layer doing this act. It is a filtering. Max pulling layer, I say you, and reduce the size of image. It is very, very, very good, and it is very, very important, and it is very, very good. But filter layer, it's a command 3 and 3 these layers, and filtering this. Filtering 3 by 3 filter and command here. Okay, and after that converted to 3, converted to this. Okay, and coming here, this area convert here, and then this area convert another filter, and then this area convert another filter. Coming down this area, and coming down this area, and this area. This is a filtering. This is my filtering for CNN convolution layers. Okay. Okay, guys. Involved input image convolution and relo pulling, convolution and relo pulling, and flattening, and another thing. Okay, guys, for input features map and output feature map, this is a you can use a Google developer. This is a filtering. My filter 3 and 3, coming. Output features map. This is the output my features map. Okay, guys, I hope you know this. Okay, also like this. Filter 3 and 3 filter, like multiply 1 convolution matrix and coming out. This is a filter, and this is a extract features from image. Okay. After that, doing everything, filtering and pulling layer. Another final fully connected layer. Fully connected layer network is a regular net which each parameter is linked to one another to determine true relationship and affect each parameter on the label. Since our time-space complexity is very vastly reduced thanks to convolution and pulling layer, we can construct fully connected network to end of classify or say the set of fully connected layer look like this. Okay, guys, come on, let's go getting and writing my code. For example, first steps, we must download the MNIST load data. This is a dataset, one of the most common datasets for use image classification and accessible from many different sources. In fact, even TensorFlow and Keras allow us to import and download the MNIST dataset directly from their API, and Keras is under the TensorFlow. Also, we use that and download it here, and I run this code. Downloading this code from the class. Train image point shape. We have 60,000 image by 28 size pixels, or test labels, or another 6. Okay guys, for example, if you want to see the train data, you can use a matplot library. For example, import matplot library, matplotlib point pyplot as plt, and matplotlib inline. Because I write here because I want to use matplotlib in IPython and online. I use this line. I write this line code. Okay, and another things, image underline index. I want to show you, for example, 520. Okay, print image underline train underline label, train underline label. Okay, I want to show you train underline label and image underline index. Okay guys, and plt point I am show x underline train img image underline index, and cmap gray, because my image is grazed. I use that. Okay, this is the error. Why that is error? Train underline labels, excuse me, train underline labels. Object is not a callable. Why this is? But because wow. This is an error because I write this image underline index and delete this. Okay, x train. Why x train? Image underline train. Image underline, because I write I train underline images. I write here train underline image and run this code. Okay, 5. You can see the train label is 5 and image is you can see here is 5. Okay, come on, and after run code RGB. Okay, after writing this code, we need to normalizing the image, because able to use the dataset in Keras API, we need 4-dimension NumPy array. If you want to use a Keras API, you need 4-dimension array. But my dimension in here is a 3-dimensional. You can see in here train image point shape is a 60,000 28. It is a 3-dimension, but we need a 4-dimensional because we want to use a Keras API. And in addition, we must normalization, because my data has always required a neural network model can achieve this by dividing RGB code to 25.5, because this is a RGB code, and RGB code is start from 0 to 255, and we must normalization that and achieve the normalization that we must uh, excuse me. Achieve the normalization, we must need divided 255. Okay guys, continue that and write in here. Write in here x underline train is equal x underline train point reshape x underline train. Okay, because train underline image underline train I write here, and I mistake that here because I change that train underline images. Train underline images point reshape x train x underline reshaping train underline images point shape point shape 0. I added one dimension, and 28 and 1 because it's gray, and x underline test is equal test underline images point reshape x underline image test underline images point shape is equal 0. I added one dimension 0, 28 and 1. And input shape, my input shape for image is 28 and 1. And x underline train is equal x underline train point as type. Why as type? Because I want normalization that, and I for achieve the normalization type, we must divide it to 255, and it is a float number. For that, we must extend use a point as type float 32. Okay, and for x underline test equals x underline test point as type float 32. Okay, x underline train equals 25.5, and x underline test equals 20 underline 5, because is divided 255 because I achieve the normalization code. Okay, and write in here print x underline train shape is write this x train point shape. Okay, I run this code and error. Okay, because in here error. Okay, we achieve 4 dimension 60,000 28 1, and we can use the Keras API. Building the convolutional neural network, we will build our model by using high-level Keras API, which use this either TensorFlow or another things. I would like to mention there are several high-level TensorFlow API such as Layer, Keras, and another things. For that, we use the straightforward API, which is a Keras, and I sequential model from Keras and add convolution to 2D and max pooling, flatten, dropout, and dense layer. And I have already talked about convolution 2D, max pooling, and dense layer, in addition dropout layer and another things, and training flatten layer and flattening 2D array and to 1D array before connecting to full connected layer. Okay guys, let's go to make and structure model for network for training that from TensorFlow point cross point models, import sequential, and from TensorFlow point cross point layers, import dense, conv 2D and drop out and flatten and max pooling 2D. Okay, after that we make model equals sequential, I copy selection and right here. Okay, everything is okay. Another things, we use model point add convolution convolution 2D. I adding convolution 2D. Okay, convolution, and use 28 neuron and kernel size, underline size. Kernel size is my filter. I use and I say you up. Okay, input the shape and another things, input underline shape is equal input shape. Okay, everything is okay. And another, adding a filtering, I use to max pooling 2D. Max pooling because I want to reduce my image. Model point add max pooling 2D and pull underline size is equal 2 and 2. And another things is model point add after max pooling 2D. I must flatten the 2D array for fully connected layer, because I want to connect it to fully connected layer. I want using to flatten. Model add flatten. Okay, after that we must say what is the neuron for fully connected layer. Model point add dense is 128 and activation is TF point NN point relo. I use the relo activation function in another tutorial. I show you what is different from another activation function, and how much we have, how many activation function we have. Okay, don't worry, I say you everything. After that, we using model point add dense dropout. What is a dropout? Because I using a dropout prevent to overfitting my network. What is the meaning the overfitting? Overfitting is I say you overfitting, it means if networking, if all data training, my data is a don't optimizer and loss function became correct, we need to delete and drop out a little train data for became better performance my networking. Also I deleted a little my train data. Okay, after that I run this line code. Okay, this is a error. Why that is error? Invalid from oh wow, why is that? Import tf, I think it's correct. Okay, I deleted that. I waiting for that. Okay, this is an error. I write here. I write like this. Okay, everything is okay. And after that we created an optimized empty CNN. Now it's time to set optimize with a given loss function that use a metric. Then we can fit the model by using our trained data. We will use the following my code and making that optimizer and loss function and metric approach, because this is a function in another part. I show you what is that and how can we use that, but we can also use another part of this tutorial, show you and define you everything that. Okay, this is a time for train my model point compile optimizer is Adam, and loss function is sparse underline categorical underline cross entropy. Okay, and metrics is accuracy. Model point fit x equals x underline train, and y equals y underline train, and epoch is equal 10. Okay guys, after that, why is that error? X underline train is not defined because x underline train underline labels become it is a correct. No, x underline train underline labels is correct. Okay guys, after that we network starting to train byte x train and y train labels. But you must say what is that loss function, what is that metric, what is that optimizer. Don't worry. In another video, this tutorial, I say you everything, and okay, everything I should say you what is that. Okay, my model is training now, starting training, and my model now is training. And congratulations, you can make your first neural network. Okay, we waiting that complete training. Guys, you can, this is a very mistake. We have made a mistake because its accuracy is very bad. I forgot writing here. I forgot writing fully connected end up layer. End up layer I can't. I add that here. Model point add dense 10. Why is that 10? Because my object number is 0, 1, 2, 4, 2, 9. We have 10 labels for each object for training that. Okay, and activation function is equal tf point n point soft max. It's good. After that, run this. Okay, accuracy is coming up. It's writing. Thank you very much. Waiting for training data and waiting that. Okay. For example, for evaluating the model, we can, because we have a x test and y test, we can evaluate this model, it is a good or bad. Model point evaluate y underline test and y on test underline labels. And another things, for test my network, I use the image underline index, for example 36, and plt point I am show and and x underline test image underline index, and point reshape that, because it's necessary reshaping that to 28, because I reshaping that for 4-dimensional for using a cross API, and here we must reshaping that 28 for showing MPLT library. And CC map is gray and grays. And another things, prediction is equals model point predict x underline test image underline index point reshaping that to 4-dimensional, because cross API need 4-dimensional 28 and 1 because it's gray. Print point arg max. Okay, is everything is accuracy is 99%. Oh, it's very good. It's very good. Model evaluated, it's good, and model predict is 7. Model predict and model image show. This is an image input my model, and my model predict that is 7. Congratulations, you build a convolutional layer network to classify handwriting digits with TensorFlow Cross API. You achieved accuracy of over 98%, and it is very, very good. Thank you very much for watching my video. Please subscribe my channel and comment my channel, because I need your support for continue this channel for recording new video for deep learning and learning Python and other things. Please subscribe my channel. Thank you very much. Good night and good time.